Pretty much, if it's a metal and a non-metal is put together, that's ionic. Covalent would be two non-metals that are going together because both of them want their electrons and neither one is willing to give them up. So, in your past classes that you might have talked about ionic and covalent and talked a little bit about the differences between them. I don't think probably you've done much with it though. So ionic involves ions, and we know those ions will be positive and negative in nature. And they'll want to come together because the result of one atom gaining and one atom losing is going to be called an ionic bond. Covalent is when we have a sharing of electrons between atoms. They share a location. Now sometimes that location is closer to one atom compared to another. And if that sharing is closer to one atom versus another, then that's called an unequal share. And the atom that where it's closer to will have a stronger share of it. Now do you guys remember a term that we had dealing with sharing, and you had different numbers that represented bigger shares and smaller shares. You remember what that term was? When two atoms are bonded together, the number indicates the share. So you remember what that term was? You should. We just tested over it. We had a trend on it. So what trend did we look at that had to do with sharing? Was it electron affinity? Nope. How about ionization energy? Electronegativity. And which elements want a bigger share is the upper right, excluding the noble gases. They have the biggest share. The biggest hog of electrons, when it shares with anything, is, and it's really not a share, is fluorine. Fluorine's the biggest hog. Okay? Anybody have a guess what's the next biggest one on there? Yep? Oxygen's the next biggest. So if it's not fluorine, then oxygen is the next one that doesn't really want to share very much. Okay? Does anybody know what the size of those atoms are on that side versus the other side?
Would they be bigger?
Nope. As you go to the right, atoms get smaller. And if they're smaller, that electron can get closer to the nucleus. And that means it has a bigger share. It has more of it. Okay? So like if you share in your family with a sibling in the bathroom, do you guys have equal share of the time? You guys have a timer that says, all right, time's up. Okay? Sometimes it's not as an equal share if you have to share a bathroom. Okay? And so that's kind of what we're talking about. There's sometimes that, sharing is really not sharing 50-50. Okay? It's a different measure. So fluorine would have a definite bigger share. If it was with any other nonmetal, it has a bigger share. Okay? Oxygen would be the next bigger share. And then it goes chlorine, and then nitrogen, and so on and so forth. So when we look at covalent, we have two types of sharing. So ionic, we want to go back to ionic and give you more information about terms related to ionic. So, guys, I didn't put bonding after ionic, but this all goes together. Ionic bonding. So if you want to write that out all in one word, or not one word, but at the beginning, and then define it as metal paired with a non-metal. Yes?
What was metallic? Because it was nothing.
Right. We're going to deal with that one later.
Okay.
So, kind of explanation and defining and those types of things, we're going to deal with that one later. Now, we know that it will be a metal paired with a nonmetal because of the electron affinity and how that works. So the metal will tend to lose electrons to form a cation. A cation is when you have extra protons and not as many electrons because electrons have been lost, and so that's positive charged. Nonmetal, on the other hand, has a high affinity for electrons. When they gain electrons, they're going to give off a lot of energy, and that's good because it gets them down to a low potential energy. And when they gain an electron, they become negative charge, and they're called anions, or an anion. So this is just the basic way of how an ionic bond forms. The ions have to form because one gives up electron, another accepts it, and we call them cations and anions. Okay? Any questions with that? You guys can look at your electron configuration, and you can kind of see which ones will tend to gain to get that full shell, or 2 full subshells, and then which ones will tend to lose. And it kind of goes along that way. Which one of these metals on the periodic table would you think would be most likely to give up their electrons? If we paired francium and sodium, which one would be more likely to give up the electrons between francium and sodium? Francium. Why? Electrons farthest away from the nucleus. Low ionization energy. Okay? Fluorine is the one on the other side that is most likely to pull an electron out. Trenton.
This is a second word on the very bottom word.
Here? This one?
Yes.
Anion. A-N-I-O-N. Anion. Alright. Now that I've given you ionic, I need to give you covalent. Now covalent, can you guys tell me which elements are bonded that are covalent? Which elements? Which group of elements? Yep, to the right of the steps. What do we call those?
Halogens.
Yep, they are, but let's include more than just the halogens. Non-metals excluding the noble gases. When they get together, they're going to be sharing. If they're paired up with a metal, we don't call it sharing anymore because it's a taking and giving type of thing. So the last slide talks about covalent. And covalent is non-metal bonded to another non-metal. So again, if you want to make this all one word, covalent bonding, or all one together without doing it layered like this, with covalent bonding and then put non-metal bonded to another non-metal. We have 2 types of covalent bonds. Ones that share equal, they play fair. We'll say 50-50. They share alike. They share perfectly. Okay? And then we have polar covalent, and they don't share equally. If they share equally, we call it a pure covalent or also non-polar covalent. That's if they share equal. If they don't share equal, but it's still considered sharing, we call it polar covalent. And there's a reason why it's called polar and non-polar. And we'll get into that tomorrow a little bit. But we got polar covalent and non-polar covalent, or pure covalent. So, let's say we have 2 atoms and they share equally. Equal, even, Steven. Alright? Let me show you what I mean. Two equally sized atoms. Two identical atoms that are nonmetals. They're sharing those 2 electrons. Are they equal distances from... Those are supposed to be the same size, so
Yeah.
they equally share it. Okay, if they're the same size, we can tell that they equally share they equally share those two electrons. Okay? If it's a situation where it's an unequal share, it might be something along these lines. Okay, so which one do you think has a greater share? One on the left or one on the right? This distance is shorter than this distance. So it's in proximity to the nucleus. This one has a greater share. Okay? Even if we make it smaller, this would be like fluorine. Okay? This would be fluorine. Now which one has a greater share? You definitely, yeah. Okay? And we know that fluorine's really small versus a lot of other things it bonds to. Okay? All right. Any questions or comments or thoughts on that? Okay? Tomorrow, we'll probably have a lab next week. I haven't, there's a lab what we'll do that is dealing with ionic, covalent, and metallic compounds, and it's kind of like the metal, non-metal, metalloid lab that we did. Something similar to that. So we'll probably have that coming up.